do is sketch this guy out, or sketch this guy out to start out with. So I have a what type of lens here? Convex. This is a convex lens, right? So his feet are already on the principal axis, so I don't have to worry about that. All I need to do is worry about his head. Cahill, give me a rule. Cahill, give me a rule.
Array non-parallel refract.
Through what? Through FT. Okay. Okay, array parallel is going to refract through F2. So what I have here, ray comes out parallel. It will refract through F2. Right? Give me another rule, Miss Newton. A rule. There are two other rules. Ms. Gaither, give me a rule.
Array going through the center will continue.
All right, array going through the center will just keep on going. Okay. And all right, chat.
This
all right, array that acted like it came from the focal point comes out parallel. I have a problem here. What is it, Shaq? Your voice has changed. Tristan's right on. Perfect. Right? They're never going to intersect. These rays are doing what? Diverging. That's the word, diverging. They are splitting up. Okay. Two paths diverged in a forest, and I took the one. You know, that frost point. If you remember, that. Yes, good. Diverge means that they separate. So what do I need to do, Miss Simmons, whenever I have diverging light rays? Trace back, right? So I'm going to trace this one back. We'll see how well my drawing did here. Something like this, right? Something like this, and we can already see that my drawing wasn't perfect on. That's okay, because I'm just trying to sketch out what I expect to have happen here. So now let's use this to make predictions. Let's see here. Kiera, please give me what you expect from the image distance. Positive or negative? Should be negative. Good. Anything else that we know about image distance? What else? I would expect, I think that it will probably be greater than 1.1 meters. Probably going to be greater than 1.1 meters, right? It's behind the object. Okay, magnification. Check. Should be positive. Okay, and bigger or smaller than 1? Bigger than 1. Yeah, greater than 1. That means that this is going to be a bigger object, right? The magnification is grow in size. All right, and what do we expect from H prime? Positive and greater than the height, which was 1.5, right? Greater than 1.5. So there's my predictions here. There's my predictions. All right, those of you with laptops, as I've said to others, I'm not opposed to having laptops as long as it's for my class. Currently, YouTube seems distracting. Okay. Now, so to do the math, what do I want to start out with? What is the name of this equation? This 1 over F, thin length. Good. 1 over U plus 1 over V. And so I'm not going to do too much here. I'm just going to plug it in and then let you tell me the answer. If you made a math error, then please go back and check. V equals what?
Oh, yes.
With 2 subfigs.
All right, negative 1.96. I need to round this to 2 sig figs, so what does it become? Negative 2.0. Okay. Please go back and double check if you made any math error there. Next, what do I want to use? Good. Magnification. Magnification equals what? Very good, Thornton. Negative v divided by u. So now magnification is going to equal negative of my negative. I'm going to use the exact here. I'm going to use the exact for now, and I'll get back to that, right? Or I'll get back to rounding off for sig figs. Divided by u, which is 1.1. So what does this magnification come out to be?
1.78.
1.78, rounded off, 1.8. Does that have a unit? No, it is a unitless guy. It's just a ratio, right? All I did was divide, so units cancel out. Okay, next equation that I want to use? Yeah,
H
prime over h. Good, so this becomes m of 1 point, what was the more precise number?
1.78.
1.78. So 1.78 equals h prime divided by my 1.5 meter height. So what does h prime equal?
2.67.
2.67 becomes 2.7 unit. What unit is this up here?
Meters.
Meters. So now we look back at everything that we did compared to our predictions. Does it all work out?
Yep.
Yes. The reason you do the drawing is so you can make predictions. Right, you can already make a few predictions just off the knowledge of the lens and location of the object anyways. But so that you can make predictions, and then whenever you do the math, you see if it lines up. Next. This guy here. What type of lens is this? This is a concave lens. So we can already tell you about this focal length here.
Negative.
Yeah, this is negative 30, right? Oh, crap. I've already got a concave lenses have a negative focal length. I don't have to tell you that in the drawing. All I have to put down is the distance, right? Distance, not the displacement. Notice the difference in the words. Displacement actually has direction. Distance is just a number. Other things might come out to be negative, but every time the focal length has to go in, it's negative. So sketching this out, let's use our rules here. Let's see, Mr. Monday, can you give me a rule, please?
It's regular straight.
All right, if a ray, I'm sorry.
If it goes straight, it goes up there.
All right, so coming in parallel to the axis goes where?
It refracts.
It refracts how? It's not going to go up. This is going to go which way, Mary?
It's going to go down because it's as if it's coming from the focal point.
Ah, good. It's going to come as if it was from the focal point, the first focal point.
Yes.
Look at the difference here, right? One that came in parallel refracts through F2, right? This line right here comes in parallel, refracts through F2. Now, instead, down here, one that comes in parallel is going to refract as if it came from F1.
Instead of just taking your word for it, can we go through a mathematical
It wouldn't take too long, but it would take longer than I'm willing to spend. You can do that yourself, right? That's not that hard. Just draw the lens, give yourself a focal length, and do the math with it. Okay. The only problem is you'd have to figure out heights and angles to the curve and all that kind of stuff. Okay. What's another rule? What happens? Keeps going. Okay. So one that goes through the center, keeps on going. Last.
Go to the second
As though it's, yeah, as though it's going to be sending it from the point that
All right. So one that would have gone through F2 instead comes out parallel. What's happening here, Sean?
It is. You have to trace it straight line.
Yes. Why? What are these rays doing?
They're diverging.
Good. They're diverging. So I need to trace back on these refracted rays. So tracing back, right? Tracing back. So I've got person somewhere about there. Got person somewhere about there. So predictions. V. What do I expect? What do I expect from the image? Positive or negative? Negative. And can you give me in relation to the distance? Do I expect it to be greater than or less than 42 centimeters?
Less than.
I expect to be less than 42 centimeters. Magnification. Positive or negative? Positive, right? It didn't flip. It stayed the same way. Okay? It was inverted and it's still inverted. So I expect the magnification to come out positive here. And do I expect it to be greater than or less than 1.5 meters? I expect it to be less than 1.5 meters. So that object got smaller, right? H prime, positive or negative? Positive 2. Why? It stayed the same way, right? It stayed the same way. So I expect H prime to be positive because I plug in H as positive. If you would like, you can come up here and make H negative 1.5, and you would expect H prime to come out to be negative also, the same sign. Okay? So for now, though, in fact, let's go back and let's make H prime negative just to show that it's down below the axis, just for, that's what I like to do here. So I expect H prime to come out negative and greater than, let's see, excuse me, this should be greater than 1, and this is going to be H prime magnification less than 1, and H prime should be less than 1.5 meters. Right? Object shrinks for those two. And then it's the exact same math we have been doing, right? And lens equals 1 over u plus 1 over v. So what does v come out to be? Negative what for me? Unit? Centimeters, so that's negative 18 centimeters with sig figs, right? Next, I want to use magnification of negative v over u. So what does the magnification come out to be, Tristan?
It comes out to be
0.43. No unit with that guy. Very good. Olivia, last but not least, magnification h prime divided by h. So please give me h prime. 0.63. I applied negative, you applied positive going in, so I'm just going to make that negative. So negative 0.63. Unit, please. Meters. You use up here positive 1.5 meters. I personally put that negative in later. Right. I personally put that negative in later. I'm sorry. Which way is this person going? Up from the principal axis or down? Down, side to side, that I'd call that way negative.
So you should draw it with his leg wrapped down the axis, like a hang on
Yeah, well, a little bit more complicated then. Any questions over this?